Hey guys, I just wanted to take a couple of minutes to go over some of the questions from today's worksheet in case you had any questions. It takes Fran 16 minutes to walk east to the bus stop 1 mile away. So that's important information. Fran immediately got onto the bus and it continued in the same direction for 17 minutes for 8 miles to get to her grandparents' house. So before you even start, it's really important to look at your two axes labels. So we see that the x-axis is representing time in minutes and our y-axis is representing distance from home in miles. So I know that my two units have to be minutes and miles, which in this example, it has. So we're always starting at 0, 0 because that's representing home. Okay, and then they're telling us that after 16 minutes, she was 1 mile away. So 16, you're going to see is in between 15 and 20, right? So it's going to be just like here. I like to make a little tick mark, okay? And it doesn't have to be perfect, but you want to be as precise as possible. So after 16 minutes, she was 1 mile away. So you're going to put your dot and then draw a straight line as best as possible if you're using a ruler. Okay, and then it says Fran immediately got onto the bus and it continued in the same direction for 17 minutes for 8 miles. Well, we already know that she was going for 16 minutes and now she's going for another 17 minutes. So if I add 16 and 17 together, I end up at 33. So then again, I'm going to look down at the minutes and 33 is going to be a little bit more than halfway. Again, these are very small segments, so just try to do your best in terms of placing where 33 goes. And I know that it's going to be 8 more miles away, right? Because it's telling us here that she's 8 miles further. Well, we already know that she's 1 mile away, so 1 plus 8 equals 9. So I know that at 33 minutes, she's going to be 9 miles away. So I'm going to put my dot up here. And once again, draw my line as best as possible, connecting those last 2 points. And that's how you do example number 1. For example 2, Joey drove to his friend's house at a constant rate of 30 miles per hour. So this information is important. 30 miles per hour. We're going to see that coming up. It took him 15 minutes to get there. So automatically you say to yourself, okay, well, the first information they gave us was in miles per hour. And now they're giving us information about minutes. So I'm going to have to do some sort of math in order to get a number that I can use for this graph. Then he stayed for 10 minutes. Think about what that means as we move on, reading the rest of the question. And then drove home at the same speed. Okay, so let's break this down. Joey drove to his friend's house at a constant rate of 30 miles per hour. So because I'm talking about minutes, and I know we're talking about minutes because I look down at the labels on my x-axis and my y-axis, I know that I'm talking about minutes and miles. So I'm going to set myself up a proportion to help with some understanding. So I know that I can go 30 miles, and it says miles per hour, but our unit is in minutes. So we need to convert hours to minutes, which is 60 minutes. So I'm going 30 miles in 60 minutes. That's what this conversion is. Okay. And I know that it took him 15 minutes to get there. Well, minutes is on the bottom, so I'm going to keep 15 minutes on the bottom. I like to keep the labels in there so that you don't mix them up, because sometimes when you abbreviate MI for miles, you mix that up with MI for minutes. So I just like to write the word out to help me be specific and avoid errors. Okay, so that means I'm going to be solving for my top number. There's a couple of ways that you can solve this. If you want to cross multiply, you're going to get 60x equals 450. When you divide both sides by 60, you're going to get x equals 7.5. Now, 7.5 what? Well, what's my label going to be for my numerator? Miles. Okay, once again, that's important because it's important to know whether the 7.5 is going to be going on our bottom x-axis or on the y-axis. And we know because it's miles that it's going to be going on the y-axis. So I'm always starting at home, 0, 0 in this example. And then it's telling us that after 15 minutes, he's 7.5 miles away from home. So 15 minutes, I'm going to put my dot in between the 7 and the 8 to represent 7.5. I'm going to draw that little hash mark so you can see what I'm talking about. And I'm going to connect my points as best as possible. Okay, that's the first part. Then it says he stayed for 10 minutes. Okay, well, if you stay, that means the distance is not going anywhere. The distance is staying the same for 10 minutes. Well, he's already traveled for 15 minutes, right? So what's 10 more minutes after 15 minutes? Well, that's 25 minutes. So at 25 minutes, he is still in the same place. He has not moved and gone anywhere. And then it says he drove home at the same speed. Okay, the important thing you need to know when it says that he's driving home is looking at the label. This label is telling us distance from home. So if you look at my orange line segment, that's showing him traveling away from home because he's going to his friend's house. Now, if I'm traveling back home, I need to go down and go back to my axis. So that means it's going to take the same amount of time. Well, we already know it's taking 15 minutes. So think, if you already have gone 25 minutes and you're adding another 15-minute trip, when you find the sum of that, it's going to be at 40. So I know that my next point is going to be at 40 minutes. And he's back home. Home is being represented by the x-axis. So I'm going to connect my two dots, and that's showing me how long it took for him to get back home. Okay, important information is that when he stays the same, right? It says stayed the same. Whoops. Sorry, use the cross out instead of a highlighter. Stayed the same is being represented by that flat line. Okay, moving on to the next example. Number 3.